Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about half subtractor circuit. A subtractor is a combinational logic circuit that can perform the subtraction of two numbers, uh, which is a binary numbers, and produces the difference between them. It is a combinational circuit that means its output depends on the present inputs only. Although in practice, the subtraction of two binary numbers is accomplished by taking the ones or twos complement of the subtrahend and adding to the minand. In this way, the subtraction operation of binary numbers can be converted into simple addition operation, which makes hardware construction simple and less expensive. There are two types of subtractors, half subtractor and full subtractor. A half subtractor is a combinational logic circuit that has two inputs and two outputs. Half subtractor is a digital logic circuit that performs binary subtraction of two single bit binary numbers. It has two inputs A and B and two outputs difference and borrow. A is called as a minand bit and B is called as a subtrahend bit. So the block diagram of a half subtractor is shown here. So this is a truth table of an half subtractor. Since it has two inputs A and B, it has four combinations 0, 0, 0, 1, 1, 0 and 1, 1. And you have two outputs difference and borrow. So we know that in binary subtraction 0 minus 0 is equal to 0, 0 minus 1 is equal to 1 with a borrow of 1, 1 minus 0 is equal to 1 and 1 minus 1 is equal to 0. So using this truth table outputs are obtained as shown here. So 0 minus 0, difference is 0 and borrow is 0. 0 minus 1, since you have a borrow 1 and the difference is 1, and 1 minus 0, difference is 1 and borrow is 0, and 1 minus 1 is 0, so both difference and borrow is 0. So next we are drawing the Karnaugh map for difference and borrow, which is shown here. In the difference, you cannot group the ones. So you are keeping as such, and you are getting A bar B plus A B bar, which is nothing but an XOR gate A XOR with B. And in borrow, you have only one, and it is given by A bar B as shown here. So the logic diagram of the half subtractor is for difference it is A XOR with B. So an XOR gate is used here, and for borrow it is A bar B. So to obtain A bar we are using a NOT gate and we are multiplying it with B using an AND gate, and you get the borrow output. Some of the applications of half subtractor are it is used in calculators. Most mini computers utilize advanced rational circuits to perform numerical tasks. A half subtractor can be utilized in a number of circuits to detect two parallel digits from one another. Next one, it is used in alarm frameworks. Many caution frameworks utilize computerized rational circuits to identify and answer interlopers. A half separator can be utilized in these frameworks to look at the upsides of two parallel places and trigger a caution in the event that they are unique. Next one is automotive frameworks. Numerous advanced vehicles utilized computerized rational circuits to control different capabilities like the motor administration framework, stopping mechanism, and theater setup. The half separator can be utilized in these frameworks to perform computations and examinations. Next one is security frameworks. Advanced rational circuits are used in security frameworks to identify and answer dangers. A half separator can be utilized in these frameworks to look at two double qualities and trigger a caution in the event that they are unique. And the last one is in computer frameworks. Advanced rational circuits are utilized broadly in PC frameworks to perform estimations and examinations. A half subtractor can be utilized in a PC framework to detect two paired values from one another. Some of the advantages are it is simple and easy to design, implement, and debug compared to binary arithmetic circuits. The half subtractors are basic building blocks that can be used to construct more complex arithmetic circuits such as full subtractors and multi-bit subtractors and carry look-ahead adders. Next one is the half subtractor circuits use only a few gates, which reduces the cost and power consumption compared to more complex circuits. And also, it can be easily integrated with other digital circuits and systems. Some of the disadvantages are it can only perform binary subtraction of two single bit numbers respectively and are not suitable for more complex arithmetic operations. For multi-bit numbers, half subtractors need to be cascaded, which increases the complexity and decreases the efficiency of the circuit. The propagation delay of the half subtractor is higher compared to other arithmetic circuits, which can affect the overall performance of the system. Let us take up some assessment questions. For subtracting 1 from 0, we used to take a dash from neighboring bit. The answer is carry, borrow, input and output. Yes, the answer is borrow. Let the input of a subtractor is A and B, then what is the output will be if A is equal to B? The options are 0, 1, A, B. Yes, the answer is 0. What does minus and subtraction denotes in a subtractor? The options are their corresponding bits of input, its output, its input and borrow bits. Yes, the answer is its output. Thank you for watching this video.